Hello and welcome. Today I'll be presenting on the topic of machine learning made easy. We will cover the journey from weather prediction model development to implementation using OpenAI, Orange and Python. Hey, I'm Ramu Gangadharan and let's get started. Our primary objectives are to train various machine learning models on historical weather data and evaluate the performance using multiple metrics. We aim to deploy the best performing model as a web API and create a front-end interface to interact with this API. Here, we will explore, develop and deploy the model using three different approaches. First, we will use OpenAI's ChatGPT by prompting it for guidance. Second, we will utilize OrangeML for model development. Third, we will combine insights from ChatGPT with direct coding in Python for a hands-on approach. We will implement the model using Python and develop the front end using HTML and JavaScript. Generative AI typically accelerates the development and deployment process. However, it's crucial to understand the fundamental programming concepts and prerequisites to ensure a strong foundation. Before we dive into the process, there are a few prerequisites. You should have a basic understanding of Python programming, machine learning concepts, and Flask for building web APIs. In terms of tools and platforms, we will be using Kaggle to download the dataset, OrangeML for quick model prototyping, Jupyter Notebooks or any other Python IDE for code development and implementation. Additionally, having skills in HTML, CSS, and JavaScript for front-end development, the ability to handle preprocessing and feature scaling will also be beneficial. Visit the URL and download Seattle weather dataset. The page also shows description about the dataset, some visualization and statistics. There is a description about each column type and its data types as well. Also, as we discussed earlier, please visit the orangedataMining.com website and download the Orange Data Mining or OrangeML. Sign in if necessary. Install locally on your machine. Typically, any dataset for that matter has to be pre-processed. In the case of weather dataset, it's already in good shape and we don't need to have any pre-processing. However, let us take a look at the information available in the .csv file. You can open this file in Excel or any other alternative tools. I will be using ChatGPT to explore the data. In this case, our ChatGPT will also be used to analyze the data. So, let's head to the ChatGPT. I am running the free version, yet the latest version of ChatGPT with limited capabilities, which is ChatGPT 4o as of the recording of this video. Hence, I have already pre-generated the answers to the prompts. All the necessary software and online accounts are already set up for me. So let's explore. Now I have uploaded the dataset, the weather dataset. As you can see, Seattle weather.csv has been uploaded to ChatGPT. And I asked a question to give some insight about this weather dataset. It came out with a beautiful answer, as you can see there. the date stamp on the dataset itself, total number of rows and the number of columns in the dataset, and each column and data types. Also, it has given the sample rows, the top 5 rows from the dataset. It has made some observations which says there is no missing values, and various other categorical descriptions. Potential analysis which we can do on this dataset is also recommended by ChatGPT. It says trend analysis, seasonal patterns, weather condition frequency, correlation analysis, and so on. Well, we are interested only in predicting this column, the weather column, based on these 4 inputs. Input parameters, which is precipitation, maximum temperature, minimum temperature, and wind speed. So my next question was very straightforward, and I asked it to give a demo code in Python, which I can use it for the weather prediction. So in no time, again came up with a brief answer, the various steps that's involved in creating a machine learning model. And in my question, I asked it to use 4 models. So it has come up with, based on this data set, it has come up with these 4 different models: the logistic regression, decision tree classifier, a random forest classifier, and support vector machines. You can also go through this. Now, one word of caution: even if you use the same prompt, copy this prompt and use it, there is no guarantee that ChatGPT or any other GenAI tools will come up with the same answer. So each time it may come up with a different answer. Please go through it carefully and use the code wisely and carefully. Okay? Because most of the times the code generated by GenAI may have some errors. So you should have an understanding of the code itself. Okay. So here is the code. It has also given me some code, the feature engineering code, and I asked it to give a step-by-step code. So that is the reason it is given in blocks. Another useful feature means with this block kind of code, we can use this in our Jupyter notebooks as a blocks to execute this code. So that even if some error occurs during the code, it will be easy for us to decode or check for the errors. Okay, so that's the various models. I'm not going to explain a lot about this now, because this is the same code I'm going to use in our third part of this video, which is implementing this in Python using Jupyter notebooks. So all you have to understand is it has come up with a complete set of code, and further, after looking at the code, I asked few more questions relevant to this model. Without using confusion matrix, can you predict which model is performing better using F-score accuracy and other result outputs? So basically, I know bits and pieces of statistics and how these models perform and the various scores or metrics it gives, which we can use for evaluation of the model. But I wanted ChatGPT to give me some idea and insight about this. So this is the question I asked, and certainly it came up again with an explanation and the code relevant to that part. The explanation, you can see the accuracy, precision, recall and F1 score. All you have to remember here is, for the ease of understanding, it predicts a value for each and every metric, or the accuracy, precision, recall and F1. It predicts a value between 0 and 1. The closer the value to 1, the higher the precision of the model. So that's the basic understanding which you need to remember. Now, within the code, I ran this code and I came back to the ChatGPT after running the code. The code, I wanted this same output to be given in a table format. So that's the reason I asked it to give it. Ask this question: can you change the code to print the result in table format? So within no time, again, it came up with a beautiful, Python code, which obviously you need to evaluate. And this is the kind of output. And again, I asked it to give what kind of output it's going to give. And this is the kind of output it is going to give if we use that code, the above code, this one. It's going to give this kind of output. Now, I didn't want to run any of the code, so what I did was I asked another question: can you run the complete code and give the results? Now, this is the power of ChatGPT or GenAI tools. I don't know where all we are given is the data set. I don't know where it has hosted this code and how it has evaluated or run this code. All I was interested was in the final output to check which model or machine learning model is doing good on this data set. So this is, as at the time of running this code, this is the kind of results or the metrics it came up with. And it also suggests that random forest is as the highest accuracy among all these 4 models. Okay. Now, obviously, I wanted this code to be taken to our Jupyter notebooks. So I wanted it to give a clean code right from the beginning, because I took it forward and backward asking multiple questions, and since I want a clean code, I asked ChatGPT to give a final verdict on this code, or the final code for this with the prediction. And this is a code it spit out, and we will use this code with some modification, obviously, to suit our requirement. In this part, we will use OrangeML to build our experiment and predict the weather information. Hey, welcome back. Let's get started with Orange experiment. When you start OrangeML, this is the first page you will land up, and let's start building the experiment. We go with new, from data, we'll go to CSV import file. I've already accessed a couple of files, so hopefully it should be listed here. Yeah, this is the file. So I just loaded the Seattle weather dataset which we downloaded from Kaggle. And from there, let me connect that to click and extend the node. I wanted to select the columns from here, so I will take that, double click to set the properties. I'm using dual monitors, so all the pop-up comes on my primary monitor. So you can see the target variable is already set, weather. I will be using these 4 input features for predicting, and that's done. I close it. I go connect. I wanted to see what comes out of this data table, So I connect to a data table, and you can see we bring it to another screen here. Okay, so those are the 4 values, and the weather is the column which we'll be predicting. Okay, I'm not changing any properties, and you can see as it's loaded, it says 4 features, target with 5 values. Okay, there are 5 classes: rain, drizzle, sun, fog, snow, and drizzle. Okay, let me close that. Once I select the columns, I want it to test and score. There you go, test and score on different models. Let me pull it there. So the models which we want to use is SVM, random forest, tree, and logistic regression. So I pull back and add a SVM, and again I pull back and add tree. Again I'll pull a node from there, and I will add logistic regression. I will add random forest. So you can arrange if you want in order. I will leave that as it is, so you can play around with it. Orange is basically a very beautiful visual tool for developing or learning ML models. So I have 4 models. Now the next step for me is to connect test and score. But what we have to do is, in case I have a test data set which is separate from this weather data set, I have taken the first 25 rows from the same file, and that is what we will be using for testing purpose. Now we need to test and score. Now I'll connect this to the data set, because that's what we are going to train on. So having done that, let me just arrange before looking at test and score. There we go. Test and score. Again, this has popped up on the other screen. So let me bring it here. So you can see we have 4 models, and out of these 4 models we have logistic regression doing very well because it's very close to 1, and you can see all other parameters is also matching in terms of the parameters which we used. If you check back in our ChatGPT, is AUC, F1, recall, and precision. Actually, it's not AUC, it's precision. So similarly, you can choose these models and you can play around with it. Now we have 4 models, and out of 4, random forest is doing good for this data set. Now we need to predict the values, or in order to predict, I want a CSV file import. So let me put it here so that it looks nice. CSV file import. All I am doing is making a right click and selecting the file from there. Go to the properties. Again, you have the recent files. There is a prediction, Seattle weather. I will leave these files somewhere, or you can just take the first 25 rows from your Seattle weather and rename it as predict, or whatever you want to use it as. I'm loading those files. I'll close this. I will take this to far and go to predictions. Now for it to predict, I want to connect these prediction, also the output coming from these models, machine learning models. So we have to predict. This is an input file, and that's the trained data set. Okay, the data set coming from this CSV file is the trained data set, and this is the data set which we are going to use for our prediction purpose. So I'll connect all the 4 models to our prediction, and then that's done. I'll double click, open, and see. Those are the predictions what we have. Okay, and out of these 5 columns, as I said earlier, I have 5 columns. The 5th column, weather, is all empty. So that's the reason we have question mark here, and we can see the logistic regression has predicted sun, random forest sun, but SVM has predicted as rain and drizzle. So you need to play around with this to create the best model and select the best model for your requirement. Now further analysis on how you can check what's happening behind this test and score, which models is doing well, where the things are going wrong. We can pull a node again, connect it to confusion matrix, or I'm just pretty smart in suggesting what tool we are going to use next. So that's the reason when you make a right click or when you pull a node, it suggests what tool will come up first. I double clicked that widget, orange widget, and you can see in SVM these are the actuals, and the total number of records is 1461, and out of this 640 predictions or the actual values which is recorded by, supplied from the data set is sun, but we have about 32 it is predicting rain, and out of which 645 is predicted as fog and snow. Similarly, you choose logistic regression, and you can see this confusion matrix, the actual versus prediction, random forest, and tree, and so on. So if you further want, you can play around, use Orange as a playground. Before you develop an actual model, get an understanding of the model which you are building using Orange. It's a fantastic tool, it's a beautiful tool. Play around and get a hang of it. So that's it actually from this video. In this part, we will use Python to develop various machine learning models, including logistic regression, decision tree, random forest, and support vector mesh. Next, we will also develop a model deployment by creating a Flask app to serve the trained models and implement it as an API endpoint for predictions. In the front-end development section, we will build an HTML interface to interact with the API and use JavaScript to handle API requests and display responses. Hey, welcome back to the third part of this weather prediction series. Let me run the first line of code. Pip install Scikit-Learn, and the star indicates that it's already running now, and we are waiting for it to complete the code. So let me, in the meantime, you can also see that the code which the libraries we use, pandas, Scikit-Learn, matplotlib, and the other sub-libraries of the Scikit-Learn. So we load. So in case any of these libraries you find when you are running this code, you got to install the required libraries on your machine locally if you are running locally. And most of the online websites where the Python is already hosted for you, there are options where you can install the libraries, but most of the times these libraries comes pre-packaged for you. So let's head forward. In this, the first code is self-explanatory. However, I would like to go through one by one. We have the file path. I have put the file with the Seattle weather, the same path as this code where I am running the Jupyter notebooks from. So once we load the weather data set, the next part of the line, date column to date time column, data type, and then we encode the weather column, drop all the columns except the weather column. If you think of a graph x and y, that is set as x. Those are the independent variables, and the weather is a dependent variable. So we set this value weather column to be on y column, y axis. And then this is a standardization method, so that all the all the independent variables are standardized. It's a pretty standard format wherein if you go and look at the statistics, it's standardized between the mean values and the 0 to 1, so that all the inputs from the independent variables participate in our prediction in a fair and normal way. Once we do that, we split the data set to test and train train and test the data set which we will be using in our weather prediction model. And you can see the test size is says 0.3, which is nothing but 30%, and 70% is our training data set, 30% is the test data set. Again, we load the required libraries here, Scikit-Learn, linear model, logistic regression, and we also load decision tree, random forest, and support vector machine. Now further, we initialize those models and we fit the models. We train, we fit the models. So once that is done, this block of the code is used for predicting the weather. The predictions are run. Okay, on the test data set, you can see that we are running the prediction on the test data set once we train the model there. Okay. And we build a confusion matrix. Once we run this, I will show you. Now I've run only the first cell of code. Let us run this cell and wait for it to finish, and then we can go one by one. Now the next cell is getting ready. You can see the first cell is still running, which the star indicates is running. Okay. Once it's run, the cell color should change here, and we should be good enough to run the next cell. As I said, please bear with me. Now, once we run that code, you see these are the 5: drizzle, fog, rain, snow, and sun. So I said the wind. So earlier, pardon me for that. It's drizzle, fog, rain, snow, and sun. So this code, now we are ready to run the split code, the test and train data set, and it's already done. So that's the reason the star has gone. Now let's train this model, and I'll run the next set of code. This is still running, and we'll come to the confusion matrix next. So that's also done for us. So we have trained the data set. Now let us build our predictions on the test data set. And this is also going to build a graph for us, which is a confusion matrix display. Now let me run that code. And if you remember in our orange ML experiment, you might have observed the confusion matrix there. It's almost pretty similar matrix which we will be developing here. Sorry, it's run there. You can see. Let me just explain one logistic regression, what it is all about. You can see in this, totally we have sun prediction is 183, but the 10 rows or the records has been predicted as rain. So the actual value is sun in this row, but 10 mispredictions has been happened. Similarly, one correctly predicted snow, but you can see snow here, one has been predicted as sun, and rest of the 6 has been predicted as rain. And similarly here, you can see it's predicted rain. The third column is rain. Okay, so but 31 cases or 31 records has been predicted as the sun. So if you have not able to get a grasp of these codes, please go and brush up your basics. There are lots of resources on the web for the basics of Python. Now we are ready to run the next line of code, Before that, let me explain what it does. Now this part of the code print. Now using this value, we can see the metrics. Random forest is doing well on this Python code. But I wanted the same code to run the same code, but this time I also wanted it to print in a table format. So this part of the code prints the metrics in this table format. Let me run this code. You can see this, all it is doing is it is running the code and putting it in a table format, the metrics. And do remember, this is all this test, the results are coming from the test data set. We are now running this from a test data set, and these are the results of the 30% of the data set. If you remember, we divided the weather prediction data set to test and train, and this train is running on 30% of the data set, the test data set. Okay. And as I said earlier, I have disabled all the libraries which I have already pre-installed, but if you do want it on your machine, if it is not loaded, please load it. Okay. Now this is the weather prediction part, and we have the test and training data set. Now this part onwards, we will be building, or we will take the code which we build using the machine learning model, the code which we saw above. I am going to package this code and host it on my local machine itself, so that we can call this code from external browser or any other application. So now the code, what we are doing is we are exposing this code, machine learning model which we built, into an API. For that reason, we need to put all this model, we need to save these model which we trained as a pickle file. So let me run that code. So that's done for us, and that's just a small output what we have. It says that the pickle file is ready. These are the required libraries, and we have these train models. We are loading these train models back to these variables: logistic regression, decision tree, random forest, and SVM. So that again, these are the scalar values which we also load, and we have the features defined. Remember, these are the 4 independent values which we need for our weather prediction. So we load that as a feature column, and this was just the test purpose, hello test. So forget about that code. And this code, when we call this predict method, it's rooted as predict, we get the request as a JSON format, in a JSON format, convert the JSON format to an input data frame, we predict those values, and now here, while predicting, we predict one model at a time. So we have a drop down list. If you think of a HTML page, we have a drop down list, and we'll be using that. So if the model name is logistic regression, we run logistic regression, and so on and so forth. Okay. Now the values, whatever we get, the return values is loaded back to the weather predictions. In the same app, this is again Python code, which we can call this weather prediction model and see what happens. But in the same notebook I cannot run, so what we can do is load a new notebook, copy this code, notebook, and I'm running this. Now this part of the code is running. You can see the star should be there, means our code is running on the port on the machine and it's listening on this port. Okay, so if I go to this code, the request code, we'll send a JSON request and then get back the same JSON reply, and we see what the response is. So that's predicted sun. Okay, let me change the values slowly to temperature, max temperature, minimum temperature, wind speed. I will say I'll increase this to 9.5 and let's run this code again. Let's see, still predicted. Precipitation, let me change as 5. Let's run this. It's predicted snow. Okay, so that's our weather prediction model. Show you one from our web page as well. So you can see this is a basic simple HTML file which we created again using ChatGPT. I will show you the prompt later on, and let's put the input same values which we predicted, which we put there, 5, 1, 5 and 9.5. so there you go, 5, 1, minus 5 and 9.5. Okay, and there we used random forest, so we are good to go. We used random forest. I'll submit. It says okay. So as you see, we got a JSON message back as a response, and it's predicted snow. Okay, so just to show you the code of what this weather HTML contains, let me go to the developer. No view source. Okay, view page source. That's the code. Again, this code has been generated from ChatGPT. I have used it to create this HTML page. So we are using JavaScript to submit this. When you click the submit prediction button, it sends the request and gets back the JSON, and that's what we display once. We have successfully trained and evaluated multiple models for weather prediction, deploy the best model as an online API, created a front-end interface to interact with the API, and we have laid the foundation for future enhancements and scalability. Throughout this presentation, we have demonstrated 3 powerful ways to develop some solution using ChatGPT. However, this raises an important question. Does OpenAI threaten the job security of developers? In the modern technological advancement, how critical is to learn the basics of programming, web development, statistics, machine learning, and related fields? These are the questions one should ask themselves. However, as a concluding note, before you edge towards an intermediate or expert level developer, it is always better to spend some time understanding the basics and get the fundamentals cleared for a strong foundation for leveraging advanced tools and technology. We work with young talents and experts to provide a solution to your need. Contact us for your academic courses and solutions, business intelligence solutions, data science, ML, and OpenAI solutions. If you think this video will be useful for someone, please share it. Please leave your comments and questions. Thank you.